AP Calculus AB, looking at Unit 1, we got extra practice. So let's check these out. For questions 1 through 5, refer to the graph at the right. Find the value of each indicated limit. If the limit does not exist, give a reason. We got the limit of f of x, and we were told that this is function f of x. As x approaches -3 from the right, if you approach -3 from the right, it's going to be approaching -4. Then you have to multiply, you have to add to that 3 times the function f, that limit as x approaches 5 from the right. If you approach 5 from the right, it's approaching -2. So let me write this here. So this is going to be -4 plus 3 times -2. That's going to be -4 plus -6. That's going to be -10. This next one, x is approaching 1. So for function f, if you approach 1 from the left or the right, it's -2. So it's going to be 1/2 times -2 plus, put 1 in here for x. What's cosine of 1? That's -1. So that's going to be -1 plus a -1. That's going to be -2. What's the limit of f of x as x approaches 4 from the left? Approaching 4 from the left is going to go to infinity. And the limit therefore does not exist. So the reason infinity is not a number. That's the reason. What's the limit of f of x as x approaches -infinity? Well, as we go to -infinity, this graph's going down forever. It's going to -infinity. Therefore, this limit does not exist because -infinity is not a number. What's the limit of f of x as x approaches -3? Well, from the left, it's 2. From the right, it's -4. Therefore, this limit does not exist. And the reason is the limit of f of x as x approaches -3 from the left does not equal the limit of f of x as x approaches -3 from the right. Questions 6 through 11, find the value of each limit analytically. If the limit doesn't exist, state why. Well, for number 6, we could factor an x out of the numerator. Giving us x times the trinomial x squared minus 2x plus 3. Cancel an x from the top and the bottom. Then you can evaluate this limit by putting 0 in for the x's. And this ends up being 3. Number 7, if you try to evaluate this directly, just like the previous one, it's going to be undefined. So we can change this a bit. First of all, I'm going to take this coefficient of 3 and put it into the front. I'm going to change tangent of x to sine of x over cosine of x. This x is going to stay on the bottom. And instead of this being divided by secant, I'm going to use its reciprocal, which is times cosine. Cosines cancel. Now we have the limit as x approaches 0 of sine of x over x. These are the same angles. Therefore, that limit is 1. So this is 3 times 1, which is 3. Number 8 is this factor. This top factors into an x plus 2 and an x minus 2. This bottom factors into an x minus 3 and an x plus 2. X plus 2's cancel. X minus 3 does not cancel. This does not exist. There's a vertical asymptote at x equals 3. And if you wanted to know specifically, is this going to go up? Is it going to go down? So we could figure that out if it's negative infinity or positive infinity. we pick a number to the right of 3, something real close, like 3.1. If you plug that into the top, you're going to get a positive. Put on the bottom, you're going to get a positive as well. So this is going to go to positive infinity, which does not exist. Why does the limit not exist? Because infinity is not a number once again. Number 9, we can use direct substitution for this. If we do, we're going to get natural log of 2 plus 2. I'm sorry, it's a negative 2 plus 2, which is natural log of 0. And then at this point, we would say this does not exist. And that's because the argument has to always be greater than 0. And this clearly is not. Good enough for that. Number 10, this is going to infinity. So this is x is going to infinity. So it's really asking about the end behavior. Just have a horizontal asymptote. And from pre-calc, we would say definitely. From pre-calc, we would say this is negative 1/3 because the top is growing at the same rate as the bottom. So then you divide the lead coefficients to find the horizontal asymptote. It's negative 1/3. You could go a more complicated process for that by dividing every term by x cubed and seeing what happens, but you're going to get negative 1/3. Number 11, this argument should have been in parentheses. Sorry that it wasn't. As x approaches infinity, 5 approaches 5, and 5 over x approaches 0. 0 plus 5 is 5. 12 through 16. Use the equation of g of x and the graph of f to answer the questions. 12, is g of x continuous at negative 2? Well, let's use the 3-part definition. 1, is g of negative 2 defined? Yes, g of negative 2 is defined. It's going to be cosine of negative pi, which is negative 1. Therefore, g of negative 2 is defined. Two, does the two-sided limit exist? Well, the limit as x approaches negative 2 from the left, that's going to be this fella. It's going to be 3. From the right is going to be cosine of pi times x over 2. We've already established that's negative 1. So therefore, the limit of g of x as x approaches negative 2 does not exist. Therefore, g of x is not continuous at x equals negative 2. For what values of a is g continuous at 2? Well, order for that to happen, the limit as x approaches 2 from the left, cosine of pi over x, pi times x over 2, has to equal the limit as x approaches 2 from the right of ax squared plus 2x. Using substitution, we're going to have cosine of pi times 2 over 2, which is going to be -1, has to equal a times 2 squared plus 2 times 2. It's going to be 4a plus 4. And solving this, if I subtract 4 from both sides, I get -5. So I'm saying a has to be a -5/4. 14. For what values of b is the function f discontinuous? Which of these values does the limit of f of x as x approaches b exist? So if x is approaching b, it's discontinuous here at 4. It's discontinuous at 0. It's discontinuous at 1. It's discontinuous all those places. Let me bring this graph down here, and we'll see if we can give reasons for these things. So when is it discontinuous? So we would say that f of x, well, let's do this. I can do better. I could say that f of -1, no, sorry, f of 0 and f of -1 are undefined. Because if you look here at 0, there's no y value, it's a vertical asymptote, and at 1, there's a hole in the graph. And I could say at 4, well, let me say this. The limit as x approaches 4 of f of x is equal to 1, but that does not equal f of 4, because that equals -3. Therefore, f of x is discontinuous at x equals 0, x equals, I wrote -1 up here, I'm sorry, it's +1. +1, +1. And x equals 4. All right, let's get rid of this graph. 15. Find the limit as, let's bring this graph back, as a matter of fact. Let me bring G down here as well so I can see that easier. All right. So this would be equivalent to the limit of g of x as x approaches 2 from the right, plus 2 times the limit of f of x, as x approaches 2 from the right. If x is approaching 2 from the right, that is this little fella here. So that's going to be a times 2 squared plus 2 times 2 plus, that is this part here, 2 times, now we're working on this part here, the function f as x approaches 2 from the right. If you approach 2 from the right, you're getting closer to 1. That's going to be 4a plus 4 plus 2. That's going to be 4a plus 6. Best we can do with that. I'm going to lose 4a plus 6, aren't I? (16) Which of the following limits do or does not exist? Give a reason for your answers. And I wish I wouldn't have erased function f. The limit of f of x as x approaches 1. Let's look back at the graph. Let me bring this back down here again. Well, as x approaches 1, that limit does not exist. The left and right limits do not agree. How about as x approaches 4? Here's 4. They're both approaching the same number. So yeah, it exists. It's approaching 1. Which ones do not exist? Give a reason for your answer. So we don't have to give a reason if it does exist, just if it doesn't. And then as x approaches 0 from the left, this does not exist. Because this is approaching negative infinity. Negative infinity is not a number. All right. How many more do we got? Quite a bundle. 17. Find the value of k and m so that the function below is continuous on this interval. Well, for this to be continuous, the limit of x squared minus kx plus 3 as x approaches negative 2 from the left would have to equal the limit of 2x minus 3 as x approaches negative 2 from the right. So if we substitute in a negative 2 for our x's, we're going to get 4 plus 2k plus 3. We're going to get 2k plus 7 on the left. On the right, we're going to get 2 times negative 2 minus 3. It's negative 4 minus 3. That's negative 7. We're going to get 2k is negative 14. We're going to get k is negative 7. So what about m? Got to find m. So we're going to have to take the limit of 2x minus 3 as x approaches 3 from the left and set it equal to the limit of 3 minus 2m as x approaches 3 from the right. That's going to be 2 times 3 minus 3, which is 6 minus 3, which is 3. On the right, we're going to have 3 minus 2 times 3. It's 3 minus 6. I'm sorry, I made a mistake here. I just put in 3 in for m, which is a terrible mistake. If we subtract 3 from both sides, we get 0 is negative 2m, therefore m is 0. All right, number 18. Find this limit. Did we already do these ones? We did the rest of these ones already. I'm going to stop there because we already did 18 through 27 on a previous review. So I'm going to chill